In this video, I will show you two different 2D high-speed peel mill toolpaths. A 2D high-speed peel mill toolpath allows for efficient constant climb milling between two selected contours or along a single contour. For single chains, you need to define the width of the cut, otherwise, the width is defined by the area between the two contours. Select Toolpaths, 2D High Speed, Peel. Leave the default chaining method and select the following two lines as shown. Ensure that both chains go in the same direction. If your chains do not appear in the same direction, select the reverse button shown here. Once complete, select the OK button to exit the chaining dialog box. From the tree view list, select the toolpath type page. You will notice that the peel mill is already selected. From the tree view list, choose Tool. Again, select the 1/4 inch flat end mill and input the following comment: machine the slot. Once the comment has been entered, choose the Cut Parameters page. Enter a min toolpath radius of 2.5%. Also, change the step over amount to 0.05 as shown. Next, enable the following options: Extend Entry and Extend Exit. Change the following values: and lastly, ensure that the amount of stock to leave on the walls and floors is set to 0. Your parameters should appear as shown. Before moving on, change the micro lift distance to 0.05. I will now take a brief moment to explain a few of these parameters. Step over sets the distance between adjacent cuts of the toolpath. Min toolpath radius defines the radius of the arc that the tool follows along its semicircular path. This value must be greater than the step over amount. Micro lift distance enters the distance the tool lifts off the part on back moves. Micro lifts are slight lifts that help clear chips and minimize excessive tool heating. Back feed rate controls the speed of the back feed movement of the tool. This allows 3D arcs between cuts to have a different feed rate than the rest of the toolpath, which can help reduce cycle time. And finally, Extend Entry Exit allows you to adjust the initial and final tool engagement with the material. From here, select the depth cuts. Ensure that this option is disabled. Now select the Finish Pass parameters. Enable this option. Input a number of passes value of 1 with a spacing of 0.02. And finally, enable the option to machine finish passes only at final depth. I will now explain a few of these parameters. Finish pass performs a high-speed finish pass along the walls of the slot. Machine finish passes only at final depth performs the finish passes at the final cutting depth only. Keep tool down determines whether or not to retract the tool between depth cuts and multi-passes. Once your parameters have been adjusted, select the linking parameters. Input a depth value of absolute negative 0.5 as shown. The rest of your parameters will remain as shown. Once complete, select the OK button to generate the toolpath. If a warning appears, select the OK button. We will now backplot and verify the operation to ensure that the toolpath is correct. Select the backplot icon. Ensure that Tool and Workpiece are enabled. Select the Fit icon and press the Play Simulation button. Your toolpath will appear as shown. You can now exit Backplot. From here, select all of the operations and verify the part. Ensure that Tool, Stock, and Workpiece are enabled. Now select the isometric view and Fit icon. Press the Play Simulation button to run Verify. Your part will appear as shown. You can now exit Verify. In this step, you will learn how to copy an existing toolpath in the Toolpath Operations Manager. You will also learn how to rechain the geometry used in the toolpath. First, we will copy the previous operation. From the Toolpath Operations Manager, select only operation number 4. Ensure that this is the only operation with a green check mark. Right-click and hold the right mouse button down and drag the operation to a point below it. Release the right mouse button and select the option Copy After. Make sure that the insert arrow is below the last toolpath. Otherwise, pick the icon to move the insert arrow as shown. We will now rechain the geometry. In the operation number 5, pick Geometry. From the chain options, click on the Unselect button to remove the existing chains. Now click on the Select button. When the chaining dialog box appears, leave the default settings and choose the following line. Once the geometry has been selected, choose the OK button to exit the chaining dialog box. Again, choose the OK button to exit the chain options. Now pick the parameters in operation number 5. Select the cut parameters. Change single chain only to left and enter a slot width of 0.5. The rest of your parameters should appear as shown. Once the parameters have been adjusted, select the linking parameters. Make sure that the depth is an absolute value of -0.5. You can now select the OK button to generate the toolpath. Select the Regenerate All Dirty Operations icon. If a warning appears, select the OK button. We will now backplot and verify the operation to ensure that the tool motion is correct. Select the backplot icon. Ensure that Tool and Workpiece are enabled. Select the Fit icon and press the Play Simulation button to run backplot. Your toolpath will appear as shown. You can now exit Backplot. Finally, select all of the operations and verify the final part. Ensure that Tool, Stock, and Workpiece are enabled. Now select the Fit icon and press the Play Simulation button. Your final part will appear as shown. You can rotate your part by holding down the mouse wheel as shown. You can now exit Verify.